Good morning. So today we're doing more with arcs and chords, chords and secants and tangents. Oh my! So using algebra to set up equations. But last week we learned the three different ways we can have intersecting secants and tangents. So something like this, where the intersection is on the inside of the circle, what do we use to set up our equation? Like, what's the... I'll give you a hint. It says angle equals...
Is it like
So is it half the difference? Or is it, see, I even wrote it up here, be able to use angle equals half the sum, angle equals half the arc, or angle equals half the difference of the arcs. So there are three choices. So this one, our intersection is on the inside. Is that half the sum or half the difference? Yeah. The angle equals half of the sum of the arcs. And maybe this is a good way to remember that. Arc plus arc. All right. Looking at number 3, here we have the intersection is on the circle. I would call this an inscribed angle. What's the setup for that? It's just half the arc. Yeah, the angle just equals half of the arc. Hello? Yes. Who? Oh, okay. Okay, bye. You too. Okay. All right. So we have half the sum. We have half the arc. And then if you, we can do sort of like this one, where the intersection on number 6 is outside the circle. What's the setup for that?
Isn't it 80?
No, just give me not numbers, just angles and arcs. Equals
Angle plus x or minus x?
Angle equals half arc minus arc. Half the difference of the arcs. Okay? Those are your three choices. Half the sum of the arcs, half the arc, or half the difference of the arcs. So those are the only three things we have to think about, and that's whether we intersect inside the circle, on the circle, or outside the circle. All right? So maybe you write that down. Outside, on the circle, or inside. That intersection is inside the circle. We do the angle equals half the sum of the arcs. And it's important that we understand if our angle is right here, then the arcs that we're adding would be those arcs that our angle would sort of eat up if we were to sort of snap that angle closed. And so here, what equation should I write?
1/2 times 75 plus 55.
Okay, that's one side of the equation. 75 plus 55, that's the yellow side of the equation. What's the left-hand side of the equation? Yeah, the angle is 3x plus 23. There's a multitude of ways that we can do this. I'm going to go ahead and just say 3x plus 23 equals half of 75 plus 55 is 120, 130. And what is half of the 30? 130. 65. Equals 3x plus 23. Again, there are a multitude of ways we could solve that, but that's just as straightforward. How do we do it from there? Minus 23. So we have 3x equals 23, 32. And then we need to, 32? 42. 42, sorry. Then we need to divide by 3. So x equals 14. Yeah, close. All right, let's look at number 3. This has the intersection of a tangent and a secant on the edge of the circle. So our setup is the angle. So the angle is right here. The angle equals half of the arc that it eats. All right, so we have the orange angle and the yellow arc. What should I write for my equation? Half of 140, that's it. What is half of 140? 70? 70. 6x minus 38. What do we want to do next? Add 38, so 6x equals 38, 108. And then divide by 6. Let's see, 6 goes into 10 one time, remainder 4. 6 goes into 48 8 times, so 18. Let's look at number 6 since we started that one. Number 6, again, angle. Angle, here's my orange angle. But my arcs that I need are the arcs that the angle would swallow up if it were to just close its mouth, okay? So I need to do some thinking here because the arc that I need is right here. I have 74 degrees, which goes on this side, but that 74 is not helpful to me right now. So what should I do?
4x plus 13 equals 1/2 of 86 minus x.
Nope. So yeah, we need to figure out how big this arc is over here. And we can do that by subtracting the other degrees that we know. So 360 minus 74 minus 86. And we get 200 degrees. So this arc is 200 degrees. And so now I can set up our angle 4x plus 13 equals half of arc minus arc. Now this is really important. We have to choose the arcs in the correct order. All right, 86 minus 200, that gives me a negative value. We need to do big minus small. And obviously the bigger arc is the one farthest away from the angle. So we need to go far arc minus near arc. Does that make sense to you? Far from the angle and close to the angle. So 200 minus the 86. All right, so 4x plus 13 equals half of, what is 200 minus 86? 114, very good. And what is half of 114? 57, good. 4x plus 13 equals 57, and then we need to subtract 13, so 4x equals 44, which means x must equal 11. Okay, so those are the 3 setups we have today, and all you have to do is figure out which one we have to apply. Half the sum, half the arc, or half the difference of the arcs, okay? So let's look at number 8. Our intersection of 2 secant lines is inside the circle. What setup are we going to use? Yeah, the angle equals half of arc plus arc. So let's figure some stuff out here. It says arc JM is 10x plus 9, so that's this arc right here. Arc NL is 28x plus 17, that's this arc on this end over here. And the measure of angle NKL, so this is my arc that they're giving me right here. So there's my angle and my two arcs that it's eating were given to me as well. All right, so what's my setup going to be? Yep. So our angle in orange equals half of arc plus arc, and those are our two arcs that we added together. So that is how we keep that straight, all right? All right, let's see. I kind of think I would like to, can I do something to get rid of the half here? Yes. Oh, thank you, Jesus, because I don't want to distribute a half, but I can multiply by the reciprocal. Multiply both sides by 2 over 1 to get rid of that 1/2. It's just going to make the algebra a little bit easier. What do I have to do on the left-hand side, though? I do have to distribute. So this becomes, let's see, half of 16 is 8x, and half of 19 is 9.5. Yes. Oh, it's times by 2. I'm sorry. Thank you. Why am I doing, oh my God. It was a long weekend, you guys. I'm sorry. We are multiplying by 2. You are correct. Thank you. 2 times 16 is 32. I was like, we shouldn't be getting fractions, right? Because we're multiplying by 2. That's so silly. Okay, so then 2 times 19 is 38. That's so much better. Okay. And then we can combine like terms over here. 10x's plus 28x's is 38x's. And 9 and 17 is 26. Thank you. All right, what should we do next?
Minus the 38 to the 36, 26.
Oh, see, I like to move my letters first, so I'm going to move this 38 instead. 38x minus 38x. I like to move my letters. I tell my algebra students, letters to the left. That's what I say, letters to the left. 32 minus 38 is negative 6x plus 38 equals 26. And then I'm going to go ahead and subtract 38. So I get negative 6x equals negative 12. Okay. And then we can divide by negative 6. So we get x equals positive 2. Are we done?
No. We got one NKL.
Yeah, we got to plug it in. We want to find the measure of angle NKL, which is right here. So that's going to be 16 times the 2 that we found plus 19. So we get 38, 48, 51. Is that right? 32. That's why. I was like, okay. 51 degrees. All right. Any questions on that? Okay. So again, it's all about the setup. Let's turn the page. I think we won't solve the remaining ones, but we will set them up. Let's look at number 10. Number 10, our vertex is on the circle. That intersection of the tangent and secant line is on the circle. So what's our setup in words? Angle equals half the arc that it eats. So let's see what it's given me. I have angle TSV. TSV. That is this angle right here. So there's my angle. And an arc SV, which is good, this is the arc that it is eating, is right there, 15x plus 13. So my angle and my arc are corresponding. The angle is eating up the arc. Does that make sense to you? Okay. All right. So then what are we going to write? Thank you. Angle is orange, and the arc was yellow. Highlighter, tennis ball yellow. All right. What do you guys want to do to solve? First step. Times by 2. Very good idea. So we're going to multiply both sides by 2 to get rid of that 1/2 issue. And then we can distribute the 2. So we'd get 12x plus 34 equals 15x plus 13. And we'll just say you can solve from there, yeah?
Yep.
Okay. All right, now the tricky parts here, let's look at number 12, I guess is fine. Here we have a secant line and a tangent line. Tangent just touches the circle right here. Our intersection is outside the circle. That intersection of our secant and tangent line is on the outside of the circle. What's our basic setup here? Arc minus arc. Angle equals half of arc minus arc. So my angle here is angle DCB. So that's my orange angle right there. And then arc minus arc would be the far arc minus the near arc. So we want arc DA, so that's right there, minus the near one, which is DB, 9x minus 4. So this one is really tricky because we're subtracting, and anytime you're subtracting, you have to be uber careful. So what should I write in place of my angle?
5x plus 11.
Is equal to 1/2 of arc minus arc. This is the tricky part. What's the first arc we're going to use?
23x minus 14.
Good. Now we have to subtract an entire arc. We have to subtract everything. This is where 90% of math errors happen. You need parentheses because we're subtracting the whole arc. We're subtracting all of 9x minus 4. What do you have to do with this negative? Distribute your negative. And that is where, that's like the second most missed algebra thing. All right. Yeah, so we can clean that up a little bit. 5x plus 11 equals 1/2. We've got 23x minus 14. Negative times 9x becomes?
Negative x plus
Negative 9x, and then a negative times negative 4 becomes positive 4. So that is really, really tricky. Make sure you distribute that negative on subtraction. Does it matter when we add things up?
No.
No, but subtraction makes everything harder. And we just have to know that we need to be careful whenever we're subtracting. What would be your next step? Yeah, times by 2 on both sides, and then distribute that 2. So we'd have 10x plus 22 equals, and then you can clean up that other side there. I guess it turns into 14x minus 10. And you can solve from there. Do you have any questions for me?
No.
All right, cool. So 3 setups, keep them straight. Half the sum, half the arc, or half of arc minus arc.